Oh, there we go. So that lights up nicely. So we've had a slightly annoying epidemic of light bulb failures in the house. So these two are definitely completely dead. This one's exhibiting some quite interesting behaviours. So let's plug this in. Sorry about the noise. And turn that on. You can see, I think you can see that. It's slightly working, a bit flickery, and very, very faint. So not working particularly well. This one is the only bulb that actually works properly. So let's plug this in. And that's pretty bright. So these are supposed to be, I think they're either 100 watts equivalent or 150. I'll look that up and put it on the screen. But I'll leave this plugged in for a while, because one thing I noticed is the base of the bulb seems to get quite hot. So I'm going to leave this plugged in, and then we'll have a look at it through our IR camera, and then we'll take some of these dead ones apart and try and diagnose what's actually happened. So I'll be back once this bulb's nicely warmed up. So while that light bulb's nicely warming up, I thought I'd take apart one of the broken ones. It was a bit of a mission. To unpeel the outer can and snap off lots of plastic, and then get rid of lots of this weird brown, I guess, kind of glue type stuff. So, but we've done it. So this is the wire that goes to the bottom of the light bulb. So that kind of sticks through the base and connects to the end cap. And then this white wire goes out to the outer can. So it connects sort of somewhere probably around here. Slightly annoyingly, the actual bulb all seems to be sealed. So getting these LED strips out will probably involve smashing the glass. So I'll do that and get those out. Looking at the circuitry, it's more complicated than I expected. So that's kind of interesting. And I suspect what's failed is either this capacitor or one of these two capacitors. So what I'll do is I'll take a photo of this, and we can have a look at the actual ICs that are being used. I guess that's some kind of bridge rectifier. There should be some kind of possibly a switching power supply IC. So that's kind of interesting. So I bit the bullet and smashed the bulb so I could extract the actual filaments. Only a small injury, not too bad. So it's quite interesting. I've taken one of these out. I was trying to power it. Unfortunately, these need a higher voltage than my bench supply can provide. I could resurrect my high voltage driver circuit. Maybe I'll do that another time. But anyway, it's a fairly straightforward construction. So we actually have 4 LED filaments coming in and 4 coming out. So probably the positive attaches to one end and the negative to the other. And then you have 4 in parallel and 4 in parallel, and then they're both in series. So quite interesting. Yeah, maybe I will try and drive this later. It could be a fun project. But let's have a look at the PCB. And talking of PCBs, we should probably mention PCB Way. So I currently have my ESP32 Spectrum being manufactured with them. So it's currently at the silkscreen stage. So getting pretty exciting. Move on to SMD assembly next. So I'm looking forward to actually getting those boards. It is the first time I've ordered so many boards, so it's pretty nerve-wracking. So this has been baking away for a while. Let's have a look with the thermal camera at what we've got. So on the end, that's about 50 degrees, 47 degrees. Not as hot as I was expecting. It feels very warm, but it's obviously not actually that hot. So let me try and arrange this so you can see. So yeah, so about 45, 46 on the end there. And then the actual bayonet, it's not that hot, 29. Inside, around 46 degrees. Definitely is warm towards the bottom, but it's not spankingly hot, is it? That's actually not that unreasonable. So interesting. Yeah. Well, let's look at the PCB, and then we'll have a look at the capacitors and see if they're broken or not. But this was running for around kind of 40 minutes, 45 minutes. It's warm to the touch, but not boiling hot. interesting. So our failure mode is still a bit of a mystery. We can actually almost see inside the bulb to the filaments. So the PCB is actually pretty simple. We have the bridge rectifier here, and then we have this WS90561 IC. So this is a 72 volt LED driver, and I think we've got a fairly kind of off-the-shelf circuit layout for this. So nothing particularly exciting here, and no clues as to what's wrong. Okay, so we've got the PCB here. I have managed to desolder all the components, but let's just check some things on the PCB. So we have our bridge rectifier here. So let's check that I've got on my multimeter on diode mode. So let's see, we should got this the right way around. Yeah, so 0.6 going that way. And we should have 0.6 going this way. Well, yeah, so the bridge rectifier is fine. There's a little Schottky diode here. Let's see what that says. So, see, 0.5 volts, so that seems fine as well. A bunch of resistors, but I can't think of anything wrong with those. So, well, here's all our components. Let's check them to see if they're right. So, I've got my nice LCR meter here. So let's check these. Let's check these capacitors first. So let's do the inductor first, since it's already on inductance. So looking at this inductor, there we go. Looks like 1 millihenry. I don't know if you can see that. Yeah, 1 millihenry. So let's check this then. Well, it looks bang on 1 millihenry, so definitely not the inductor. Let's try this capacitor. So this is a 3.3, come on, focus camera, 3.3 microfarad. So let's go on to the microfarad range. Let's see what this is doing. Three microfarads, so that seems pretty reasonable as well. Okay. And then we have this one, which is supposed to be a 4.7 microfarad. So let's try that out. Four microfarads, so seems reasonable as well. And then finally we have this this little capacitor here. Difficult to read because it's covered in gunk. But let's just measure it and see what it is. So looks like that's 100 nanofarad. So interesting. As far as I can tell, all the components seem okay. The bridge rectifier is fine, and this diode's fine. I guess this chip, maybe that's gone faulty. It's entirely possible. I was thinking about the temperatures we measured. It was 50 degrees on the actual end cap. So this PCB is getting pretty hot because it's inside the bayonet. So I don't know what the temperature was inside, but pretty toasty. So yeah, a mystery. But these bulbs all do seem to be failing, so goodness knows what's happening. So I've made myself a very Heath Robinson power supply here. It's currently 126 volts. I mean, it's incredibly low current, but I do need to be a little bit careful that I don't zap myself. So let's take this filament that I chopped out earlier and see if we can get it to light up. So let's see. I don't know which end's positive and which one's negative. So let's try. Oh, there we go. So that lights up nicely. So that filament's definitely working. Let's try all these ones. So let's try connecting this end to positive, and then this end negative. Yeah, so those three work as well. And what about these four? I don't know which way round to actually wire this up. So let's try positive there, negative there. Oh, nothing. That's interesting. Let's try swapping it around. Positive there. and negative down the bottom, still nothing. So that's kind of interesting. What I'm going to do is I'm going to chop all of these out individually and we'll test them all separately. So let's do that quickly. Now it might just be that because there were 4, my little crappy power supply couldn't actually drive it. But let's have a look. So we've got our 4 here. So sure must be a slightly easier way of doing this. But let's try them one at a time. So plus, minus, no, other way around. Yeah. Plus, minus. Oh, well that's interesting. This one appears to be completely dead. Fascinating. Let's put that to one side. Let's try these other ones. Maybe I'm doing something wrong here. Oops. Negative, positive. Nope. Positive, negative, nothing. Let's double check. It was working. So let's double check I've not broken something. Oh yeah, that lights up. Interesting. And these 3 all light up without any problems. These ones appear to be not lighting up at all. So let's see. Positive, negative, nothing. And negative, positive, completely dead. Well, that is interesting. So that appears to be dead. Let's check this one. Negative and positive, absolutely nothing. Let's flip it around. Negative. Yeah, this one's not lighting up either. So, well, I guess this must be the cause of our problem. All of these strips have died. So what probably happened, I surmise, is possibly one of these went open circuit, and then all the current started flowing through the other ones, and then they slowly died as well because there was too much current flowing through. So, and then when they all died, nothing worked anymore. The light bulb stopped completely. So, well, I think my conclusion is that these 4 strips are dead. Now these 4 strips are working nicely. Let's make sure I get it the right way around, make sure I'm not going mad. Yeah, that lights up no problem. So yeah, interesting. So the circuit's probably fine, the PCB's probably fine. It's actually these LED strips that have been failing. So yeah, that is completely dead. It's not lighting up at all. Interesting. Well, I guess we've diagnosed our problem. Yeah, very cool.